Once we have reviewed the creational design patterns, we will begin to look at the structural design patterns. To start this section, we will study the design pattern called adapter. The intent of this pattern is to convert the interface of a class into another interface that clients expect. The adapter allows classes to work together that otherwise could not due to the incompatibility of the interfaces. Now, let's see what this definition refers to. First, let's understand what the definition refers to with an interface. In this definition, the interface refers to the set of methods that a class exposes so they can be invoked from a client. On the other hand, the client will be any object that needs to make these calls to the class interface. However, there may be occasions when some classes have interfaces that are incompatible with our system. For example, when using a third-party class library, they will not be able to connect to our system natively. It is in these cases where the adapter design pattern will help us solve this problem by acting as a special connector that will allow us to adapt the incompatible class to our convenience. Let's illustrate this better with a practical case. Suppose we are creating an application that allows us to carry out a nice preview in the format of dynamic charts, as we see on screen. Or this other visualization. All of them have in common that they use a spreadsheet document as a source. If we were to translate this application into a class diagram, we could start by seeing a class called Spreadsheet, which will be the class that contains all the information to fill the interactive document. On the other hand, we will define an interface called iGraphic that will contain a method called Generate, which will be responsible for executing the calculations for each type of chart. We see that this method receives a parameter from the spreadsheet document. The implementation of this interface will be given in each of the concrete classes that will be responsible for processing the information of the spreadsheet document according to the type of chart we want to display. Finally, we will have a class called Dashboard, which we imagine as the container that will control the rendering of each of the types of charts. This class will be initialized with the spreadsheet document and will contain a method called render. This method will generate the type of chart we want to render and will be responsible for displaying it to the user. Looking at some code, this is how the invocation to the class would look like. First, an instance of the dashboard would be created, passing the reference of the spreadsheet we need. Subsequently, the rendering would be carried out by passing as a parameter which is the format of the chart we want to display. In this example, a bar chart race type chart. Everything works wonderfully, until one day we find a third-party engine that allows receiving a spreadsheet as input and carrying out rendering on a map. It sounds great and we want to integrate it into our system. However, when comparing the classes, we see that the class implementing this functionality called Earth is not compatible with our system, since it does not implement the iGraphic interface. Remember that this is a third-party component and therefore we do not have access to the source code. If we try to use it in our system, we will get an error that indicates that it is simply not possible to convert an Earth data type, which is the new class, to an iGraphic type, which is the abstraction we must pass to the render method. This is where the adapter design pattern will help us solve these types of problems by allowing us to create an adapter for the new Earth class to fit into the system. I am now in Visual Studio. Let's examine this project that I have prepared to see this design pattern called adapter. In the slides, I mentioned that we had started to define an interface called iGraphic that contained a method called Generate. This interface was implemented in a couple of additional classes, such as bar chart arrays. we see that it is implementing this interface, and here the generate method is being implemented through the printing of a text that says showing bar chart graphic. We also have a class called plotting competitors that also implements this interface, but in this specific case, a specific message is being displayed related to the implementation of this class. We also have a class called spreadsheet that contains a single property. This class would be responsible for carrying out the storage of the information of that spreadsheet document. But to make this example simple, we will leave the class with this single property only. We have a class called dashboard that receives a spreadsheet type element as part of its constructor, which is the document that we're going to process or work with. We have a method called render that receives the type of graphic that we want to display as part of our application. Finally, the generate method is executed, which, remember, is the implementation of this interface called iGraphic, passing as reference the document containing all the information. Finally, as part of our application, we have a class here called program, in which we will create a new instance of this dashboard, passing the spreadsheet. Finally, we invoke the render method, passing the reference of the type of graphic that we're going to display. In the slides, the problem I had mentioned earlier is that you may have a third-party class, as in this case, we have a folder called plugins, and we have a class called earth, whose method is called render. This class exemplifies the part of a new component that we would like to use, which receives a spreadsheet type as part of this method called render. However, since it does not implement the interface called iGraphic, we cannot use it as part of the system. If we try to create a new earth reference as part of the render method, it simply tells us that this is not possible. If you think it would be as easy as implementing the interface as part of this class, remember that we are simulating that this class is part of an external framework. Therefore, we do not have direct access to the code. Next, we will see how to solve this problem through the adapter pattern. Let's analyze the structure of the adapter design pattern. This pattern begins by starting that in the system there must be an abstraction of the target type, or in this case of the diagram, it is called target. This target abstraction must be a valid abstraction within our system and will be implemented in the adapter. The adapter class or the adapter will be the class responsible for implementing the abstraction, specifically a method that in the diagram is called request. Within this method is where the conversion processing takes place. For the adapter to carry out the necessary conversion, it requires that there is a reference to the class we want to adapt, which in the diagram is called adaptee, which contains an already implemented logic. Finally, a client class will be the one that maintains a reference of the target type to carry out the adapting processing. Translating this diagram to our project, our target abstraction would be the interface called iGraphic, and the method that we are interested in being implemented in the adapters is the method called generate. Remember that the purpose is for us to be able to pass an iGraphic type element to the render method of the dashboard. Subsequently, we should create the corresponding adapter. In this case, the adapter is going to be called earth adapter and contains the generate method. On the other hand, the earth class represents the class of the external library and contains a method with a different name called render. This class is the class that we must adapt to be compatible with the system. Finally, the dashboard class is the one that will interact with the abstraction to execute the render method correctly. Let's see how to carry out this implementation in code. We are going to create and implement the pattern called adapter. How can we do this? Well, we already have a large part of our classes that we need in the slides. You can appreciate or review the video of the slides again to see which classes we already have. In our specific case, we need to create the adapter that will allow us to connect our system with that class called earth, which is part of an external framework. What can we do? As part of our folder called framework, we're going to create a new class that will be our adapter class, which will be responsible for carrying out the conversion process of the external class so that our system can work with it. So let's call it Earth Adapter, for example. We already have our class ready. Let's make it a public class, and this class will implement the interface that interests us, which is iGraphic, which contains the method called generate. The second step we have to do is communicate with that external component, with that external class that we want to use as part of the system so that it can be used as part of our adapter. How can we do this? We will create a field of the type that interests us, which is Earth. I have to import the namespace and let's call it Earth, for example. Later, we will create a constructor as part of our adapter that receives a reference. We even have a Visual Studio suggestion that creates this constructor automatically. In this way, we will be able to maintain a reference to this external class. Our adapter will work on this method that is valid within our system to carry out the conversion or use of the external class. What are we going to do in this specific case? Well, let's remove this throw not implemented exception and instead we will invoke Earth. Render is the special method, the method that is part of that external class and that we cannot use natively in our system. We will indicate that we want to use this method. We will pass the reference of the spreadsheet document. In this way, we are using a method foreign to our system, but encapsulating this generate method and the logic that refers to the external component. Thus, we are implementing the pattern called adapter. With this change and adapter that we have implemented, let's return to the program. Instead of using Earth as part of the reference for the render method, let's indicate that we need to use our adapter called Earth Adapter. As part of this constructor, remember that we have to pass a reference to the external component, which in this case is Earth. We will indicate that we want to pass a new instance of Earth, but it is being encapsulated in our adapter. We already saw internally how it works. When running this application, we see that it is being implemented and showing the message corresponding to this component, which is the rendering part of an Earth visualization. In this simple way, we have successfully implemented our adapter pattern.